So this evening's talk is by Anthony Smith. I met Anthony the first time on a project in Leicester. You might not remember that. He told me at that time that he was in the process of starting up his own business, IPIG, interesting projects involving glass. And I've worked with Anthony on a couple of jobs, a couple of Maggie's jobs where I twisted Anthony's arms to get involved. One was with DRMM, Maggie's at Oldham, and then the Maggie's with Heatherwick at Leeds, which has just won a major award, Civic Trust Award. Very complicated jobs, very challenging architects, and I knew that Anthony would deliver, and he certainly did. An excellent engineer. Anthony started in 1995 with Arup Facade Engineering. Go back to 1995, I don't think there were many standards with regards to facades, as I remember. You could have counted them on the fingers of two hands, I would have said. And he was with them until 2006, and then he and a couple of colleagues set up IPIG in 2007. They've done a lot of very interesting projects, which include mainly construction bespoke glass. And he did the skylights for the Copenhagen Metro, the Flintholm Station canopy in Denmark, and the structural glass staircase in the Danish National Bank, which I'm guessing is somewhere in Denmark. So loads of experience. And I've been talking to Anthony over the years, and I asked him if he'd be kind enough to pick a project that he's dealt with and give us a presentation. If people could keep their video links off, that would be fantastic. If you've got your video on, could you turn it off? That would be great. Thank you very much indeed. And just keep the videos off. So Anthony, if I may, would you be kind enough to share your screen, and we'll hand it over to you. Questions, you can ask questions on the chat line, or at the end, we'll try and open up individual microphones so you can ask your questions direct. So Anthony, the stage is yours.
Right, well, thank you very much for that introduction. Chris, you've taken some of the wind out of my initial opening statement, but never mind. It's very strange to sit here in my deserted office and talk to my laptop for the next 45 minutes without really getting any sense of feedback. So hopefully this will be informative, enjoyable. There's no need to take any notes. It's not particularly technical. I'm going to tell a story. I'm going to show a project that's not been told before. It's not been seen before. It's in a private property somewhere in this country, and credit to the client's representative for letting me tell this story tonight. A little bit of an introduction, just to build on what Chris said. I started IPIG, inspiring projects involving glass, back in 2007, as Chris said, and we set it up, myself and a couple of colleagues, to focus on the design and construction of challenging glass projects. As Chris mentioned, I originally worked for Arup Facade Engineering, worked on a number of projects at Stockley Park, worked on several projects in Denmark, worked on the Glaxo World Headquarters building, and a number of other structural glass projects around Europe. I was very blessed, I was very lucky to be working there in the late 90s with a really great group of people, and as Chris alluded to with regards to the lack of codes of practice, we had a very enjoyable time making it up as we went along. What we've continued to do within IPIG is to combine the design skills that some of us have with the technical knowledge that others of us have, and understanding of the capabilities of our suppliers, and try to synthesize those into really quite beautiful projects. A lot of the stuff that we do is for private clients, and very little of it has been told openly. But I'm going to take you back to around about 2010, 2013, and we were first asked to get involved in the scheme design of a glass ceiling for a private house in London. And we were given this image by the architect who was involved at the time. And he said, you know, this is a glass ceiling, or this is a decorative ceiling that they have in one of the rooms in this house. And could we realize it? Could we come up with some ideas as to how to make it? It was just an image. We were also pointed towards the Daily Express building in Fleet Street as an example, and you'll see some of the design cues from this building, Art Deco style of interior, and the coffered ceilings, the textured plasterwork. So you'll see some of these cues repeating through and being incorporated into this particular project. We were also pointed by the interior designer towards the Palm Court Lounge at the Berg Island Hotel in South Devon. Again, another example, and this started our design. It started us thinking about how could we construct the ceilings for this project, incorporating glass, incorporating some form of backlight. It's worth noting that these ceilings, or this particular project, is underground. It's located in a basement, so there is no very little natural light. The box, the construction that it is in, is a large subterranean concrete volume, and we had to put this glass ceiling together with switchable, with adjustable, with controllable backlight, and with this great kind of image that they wanted to create this grand interior space. So our first rendering, our first image was this one, which you see before you. What you'll see in the middle, I don't know whether my cursor works, there is some very small oculi. These oculi are set into the external terrace outside of the property, and so they were originally intended to allow natural light into the basement, just a very small amount, approximately 1.4 meters diameter. And the ceiling on these projects, these glass domes, are about 8.5 meters in diameter. And we worked with a local supplier to start to create some glass samples to see how these might work, to see how they might be backlit. The very simple mixtures of different depths of sandblasting, different types of surface texture for the glass. We took some of the cues on colour from the projects that we'd been pointed towards, and we started to look at different shades of blues and different shades of translucent blues, and to prototype or to sample some of the different Van Siever ranges and different combinations of interlayers. At the time, the frame was intended to be a brass frame. That changed during the course of the project. So we looked at backlighting, we looked at different effects that we could achieve with the blue glass. But it wasn't really being sold to the clients. It's worth noting that there was an interior designer. There were no architects involved on this particular project. There was a structural engineer for the concrete box, but we were responsible for the design of the glass, the specification of the glass, the design of the framing, all of the suspension system. Basically everything that went inside this concrete box was down to us. And we had direct contact with the client and the client's representative. And for the first few months, it was a little bit like playing pin the tail on the donkey. We're trying to second guess exactly the direction that this project was going to take. We were given a mood board by the interior designer, and it was something that was incorporated into several of the other projects that they were working on with this particular client. And there was a lot of textured glass. There was some deep sandblasted glasses. There was some Lalique decorative screens. There was a lot of integration of lighting, integration of texture, different variations on reflectivity, There were some very rhythmic patterns. There were some very random patterns. And we kept on coming back to this project, the Daily Express building, with its curved and coffered ceiling and its interface around the edge of the roof. And a very strong desire came out of the discussions that we were having with the team for a kind of golden colorway, if you like, lots of gold, lots of reflection, lots of texture, lots of patterning. We also, and I'm going to acknowledge a number of people who are involved in the in inspiring us actually as the process went along. We were introduced to a process that's known as glue chipping glass, and I don't know how many of the people who are listening and watching this evening understand how this process works, but basically glass is sandblasted, and it then has a glue applied to the surface, and it's just left. And that glue slowly dries out, and the glue binds into the texture from the sandblasting, and it plucks the surface of the glass off. And it creates this very crystalline, very natural type of pattern in the glass surface. It's completely random. Well, it's not completely random, but it's it forms naturally. It's almost as if crystals are growing in the surface of the glass. So it can't be controlled other than by the intensity of the sandblasting. It can't be given any kind of direction. It just gives this really quite magical surface texture to the glass. And it became apparent that this was something that the client and the design team wanted to incorporate. So several iterations later, this was the image that sold the job for us. It's we use Autodesk Inventor as a design package. This was something that we put together. We tiled it with some gold photos, and the client basically looked at this and said, "Yep, that is what we want." So, having come up with the image, we then had to come up with a solution as to how to build it. The overall size, as I mentioned, it's approximately 8.5 meters in diameter, and if we go back, sorry, you can see it's divided into 12 segments or 12 subdivisions with the central funnel in the middle. So we understood that we were going to have to make some kind of funnel section out of glass, and then we're going to have to make these petals. And do the petals, are they made out of one piece of glass? Are they made out of a number of individual pieces of glass? What's the solution? And if you cast your mind back to the Daily Express building as an inspiration to this project, the ceiling there is entirely made up of curved surfaces. So we wanted to get a curved profile into the glass, but we weren't really sure how this curved profile was going to work. You can see here some of the early stage sketches as to the approximate proportions. It's maybe just over 4 meters from the center point out to the perimeter, subdivided into 12 or 24 pieces. You get an arc length of around about 1 meter at the perimeter. And we wanted to get some texture, as I mentioned. So we were looking at a valley and a ridge and different types and orientations of glass. And then I thought back to this particular project, which everybody who's ever passed through ARUPS as an organisation will be incredibly familiar with, finished in 1973. What was very, very clever, and one of the turning points in the development of this project, was that a decision was made where every single one of the tiles on the roof of this building is curved to the same spherical form, which means they're all made in the same, or they were all made to the same geometry. They could have all been made in the same mold. And we took that as a method or as a way of introducing some curved glass, but introducing some curved glass in something that was vaguely economical. Put very simply, every single piece of glass on the petals of this ceiling is curved to an 8-meter radius. So this sketch indicates that if you take some spherical surface, and you take another piece of the spherical surface and you pull them together to form a ridge. That's essentially what we did with the design and development of this particular surface. So we have the funnel sections in the middle. We've got 12 left-hand petals. We've got 12 right-hand petals. And the funnel section in the center started out as a toroidal surface, running from the oculus in the center out to the interface where the funnel then joins the petals. That ended up having to be, because of the shape of the concrete, we ended up having to adjust that geometry and flatten it out. And we ended up with a surface which is anticlastic. It's curved in one direction effectively in the x-axis. It's curved in the opposite direction in the y-axis, and it actually introduces a fold down the middle of the glass, where what starts out at the top of the glass as a smooth curve ends up joining the left hand and the right hand petal here. There is a slight ridge line, which I'll show you shortly. The subdivision of the glass was worked out in a fairly traditional Art Deco style pattern, and this is the finished, or this was the final plan of one of these glass ceilings. There are actually 5 of them in a line, so there is a fairly large degree of repetition, but this is the plan of one circular glass ceiling with the oculus in the middle, the 12 funnel pieces, and then the 12 radiating sections behind. And this is the cross section through. I mentioned that the shape of the concrete was such that the funnel pieces here needed to be smoothed out a little bit. There was, or still is, an oculus in the center. The oculus was intended to bring in natural light. Unfortunately, it didn't allow enough in, and so between the glass skylight, which still exists, and the glass funnel, which we installed, there is a glass diffuser panel, and then there's an array of 120 LED lights which simulate natural daylight and provide an incredible blast of light into the basement space. There's then a series of radial suspension frames which are bolted into the underside of the concrete, and then the entire underside of the concrete is sprayed with an acoustic and fire-resisting sort of surface finish, which is looks a bit like it's just a kind of fluff, if anything, but it acts to diffuse the uplights, which we also had to incorporate into the framing of these skylights. So the glass schedule, this is one of the 12 segments on each of the roof lights. So you've got the panel number 1, the funnel piece, and you've got a further 18 pieces forming the glass ceiling. 18 times 12, 228 pieces of glass on each of the domes, plus the central diffuser, which slides out of the way to access the lights above, gives you 229 pieces. So a total of 1,145 pieces of glass, all shaped, all curved, all laminated, and all with the glue chip and the surface feature. And then the framing, series of bespoke frames, which I'll talk through as well in a moment. So if we look at the framing, before we get back to the glass, we extruded bespoke aluminium sections, which is this profile at the bottom. This is what people wanted. They wanted something which wasn't just a flat section. So we extruded the section that you see in front of you, and then we rolled that and welded it to profile cut ribs. So this is, there are 12 of these ribs. They're all shaped, and the profile here allows the welds to be inserted in each of these recesses, and therefore it gives the glass a nice bearing surface to sit on that isn't obstructed by any of the welding. To construct the doubly curved frames, we worked with a joinery company out in Oxford, and they created these CNC timber jigs for us. And as I said earlier, I'm going to acknowledge a whole load of people towards the end of this, where and the part that they've played in helping to realise the different stages of the job and the different materials that we've selected for incorporating into this. What the joiners did for us is they made these frames. We wanted to be able to locate all of the individual strips of aluminium and accurately weld them. They came up with the idea of these removable dowels, so that you can put all of the bits of metal in, you can tack them together, and then once everything's tacked together, obviously given its geometry, you can't lift it out of a mold, but you just remove all of the dowels and lift it off the jig. So you see here, this is a in process or in fabrication photo showing the various strips of metal, and this is it with one of the primary ribs attached. And then a brief jump forwards to the installation. You can see the frames on site prior to glazing, suspended off Halfon channels, which are bolted to the concrete. You can see the acoustic and fire protection up here, which acts as a diffuser. And you can see up above, you can see the sliding diffuser panels and the array of LED lights. One of the domes, I said there are 5 of these ceilings. One of them is actually flat, so you've got a slightly different profile of frame on this ceiling. The remainder are all doubly curved. So back to the glass. There was a strong desire to use a golden coloured glass. These are examples of the glue chipping effect here in the background, and this is the glue chipping when it was applied to the gold reflective glass. And it needed to be backlit, or there was a strong desire for it to be backlit as well. So here we have some prototypes that we did with the glass when it's face lit on the left and when it's backlit on the right. Now, some of you might be looking at that and thinking it's not particularly impressive when it's backlit, and we'll get onto that again a bit more in a short while. It's a very, very fine balance between something that looks golden and reflective and something that looks orange and plastic, and that was one of the major challenges towards the completion of the job, was to get the light balance right. So a word about the glass. The glass was Pilkington Eclipse Gold, which is a pyrolytic coating from Ohio. Pyrolytic coated glass manufactured in Ohio. Used to be used a lot last few years of last century, not been used an awful amount since then. But we ordered a number of end caps of glass from the States and had them shipped over to Europe. A word of warning is that when they pack these glass end caps into containers, they use a very special crane, which nobody in Europe has, to be able to unpack the containers. So we ended up having to remove over 100 sheets of glass from the container manually, and then stack them all prior to the next stages of processing. So we received over 100 sheets at 3 meters by 2 meters. The process involved us then cutting the glass from 3 meters by 2 meter panels into 1 meter by 2 meter panels. Those panels were then sandblasted, and they were processed through the glue chipping process. The kiln that is used to dry the glass in glue chipping only has will only take 2 meters by 1 meters, hence the need to cut the glasses down. And then once the glasses had been chipped, they then needed to be CNC cut into all the individual shapes, which you'll see shortly. This is the production drawing for the funnel panel. As you can see, it starts out at the top as a singly curved profile, and then as you run down the slope of the glass, there is a fold that is introduced, and it ends up terminating as two flat edges or two flat lips at the bottom of the glass. Now, we worked, this isn't a secret, we worked with Sunglass on this, and I must say that that Jerry, who many of you will know, and Mr. Lincetto in their production were both absolutely fantastic. Initially, when we approached them, they said they couldn't do it, but we persevered, we convinced them, and they ended up through a series of trials and prototypes. The first few panels weren't all that attractive, but there were more attempts. Slowly got smoother and smoother, and then they started curving some of the gold glass that we had sent over. Now what you can see there, if you look very closely, is that the coating actually cracks a little bit, but given what we were going to do with the glass, that didn't matter. So a lot of the normal specification requirements with regards to optical clarity and view through the glass, and not damaging the coating of the glass, all of the normal things that would be specified by a facade consultant were not appropriate, because it was to be totally internal, it was to be laminated with the translucent interlayer, and it was to be backlit. It didn't provide any amenity, it didn't provide any view, it was purely a decorative surface. And the end result was really, really fantastic. We couldn't have asked for any better product from Sunglass on this. The final specification was 6mm annealed with the cracked ice texture on surface 1. We then had 5 separate interlayers, giving us the translucent and giving a little bit of extra colour. And then we had the low iron glass contra panel laminated to the obviously to the back. Going back to the framing, we sent one of the modules of framing over to the factory in Italy, and every single panel that was processed was trial fitted into its appropriate slot, or its appropriate final location in the framing, so that we knew that it was going to fit. It's pretty straightforward, but given the curvature, given the number of panels, it was a process that we asked for. The most important was obviously panel IPG1, which is the one right in the foreground, but this is the size and shape of all of the other glasses. Sunglass helped us out tremendously in that we knew what it was we wanted as an end product. If we go back up through the process a little way, the glasses came over into Europe. They were, as I said earlier, they were cut, they were chipped, they were then CNC cut in one factory. The factory that did the CNC cutting to a profile which was provided to us by Sunglass also CNC cut the contra glasses, and they cut them to very slightly different dimensions so that the glass panels would fit into the frame, wouldn't foul in either insertion or subsequent removal. And then 1140 curved laminated gold textured glass panels were painstakingly made and laminated and checked and shipped to us in London. This is the same frame with all of the sort of field glass panels shown in place. it's at this point that I think I'd just like to highlight a number of people who were involved. Obviously, the glass came from the United States. So each of these green dots is a factory or a location where something was done for the project. There's a guy, Tony Smith, no relation to me, who worked for NSG Pilkingtons in the States. He handled all of our all of the procurement and all of the shipping and bringing the glass over into this country. We had a lot of assistance from, well, the glass was processed by Sas van Gent when they were still in business. And so Frank Lefebvre and Francis Cerise and Klaus Langot and Darren Kearns, a number of people who were involved in XXL, which is part of Saint-Gobain glass. They were hugely inspirational and hugely helpful. The glass was passed through Myvert Glass in Belgium. Tough Glaze in the UK did all of the lamination of the flat panels for us, and CG Joinery made the jigs for us. And then, as I mentioned earlier, Jerry, Mr. Lincetto, Michaela, the team at Sunglass were extremely influential in getting the glass, in enabling us to get the glass made over in Italy. We had a very special, very patient and very enlightened client team who always strove for exceptional outcomes. I think probably one of their best characteristics was they were very patient. This process took 4 years from start to finish. And you see here a couple of the photos as we started to install the glass. You see here the frames that are suspended from the ceiling. We also designed a series of light fixings. So these fixings clip over the ribs of the frames. There's a series of LED lights which are fitted to all these clips. What you also see running through the frame here is the suspension point for a glass sculpture. So one of the 5 ceilings that we installed had a truly incredible, truly magnificent glass sculpture suspended underneath it. And the suspension points for that sculpture passed through the glass line, through the ribs, and were an entirely separate structural system bolted back up to the brackets fitted to the concrete. You see here a number of the funnel panels starting to be installed, and here they look gold. They look gold and they look reflective. This on the perimeter is exactly the same glass, but here it looks orange and it looks plastic. Here you see the lighting array, the diffuser panels. And then this is the view up above the glass once we'd started to install quite a lot of it. You see the suspension frame, you see the LED lighting chains, all the finish on the concrete which diffuses the uplights. And here you see the very final piece of glass being installed. It's quite a simple process. Just feed the glass up through its own void and then lower it back down. There's a gasket race around the inside on the back side of these, and the glass panels just rest with gravity. There's no wind uplift. There's no weatherproof requirements. They're purely decorative. And this is the way in which the ceilings were seen when the installation was completed. Now, it's very fair to say this wasn't exactly what was expected. It doesn't look as spectacular as we hoped it was going to. We'd trialed and prototyped the glasses. We trialed and prototyped the paint finishes. There's obviously a diffuser there's obviously a lighting array up above the diffuser panel, but as I mentioned earlier, there is this battle amongst with regards to the lighting to get the lighting balance correct, to achieve a gold reflective dome as opposed to an orange plastic dome. This is a photograph of the finished article. there's a lot of non-directional bright light sources that we added into onto the top of the ceiling. So above this coffered opening, there's a number of pebble diffuser lights beneath the glass, and there was a lot of time spent fine-tuning the balance between the backlighting above the glass and the face lighting below the glass. It was not really an intuitive process to get to the final effect. The final effect is spectacular. Unfortunately, it's hidden from view. It's, as I say, it's in a location that we can't really divulge. But the combination of the glass and the framing has subsequently been gold leafed, and so that's why it appears to be a different color. The glass has got considerably more face light underneath it than was originally envisaged, which is why it looks much more reflective. The finished article is really quite spectacular. As I said earlier, this is one of 5 ceilings in a line along the center of this subterranean space. The project, which I've just explained, just talked about, as I say, it's not been shown before. It is in a private location. Unfortunately, it can't be visited. But working with the same engineers at Michael Barclay Partnership, who we worked with on this job, we've recently completed this job, which can be visited. It uses very similar ideas. It uses very similar design principles. This is outside. It's in Upper St Martin's Lane in Covent Garden. It uses a series of fabricated metal frames that have been given a special paint finish. And it uses, I think, 455 glass panels. These ones have dichroic finish to them instead of the glue chip and the gold reflection. And so it takes some of the technology, some of the ideas, some of the principles that we have developed on previous projects and use them on the next one. It's nice to be able to repeat some of the details that we've used. It's nice to be able to do something occasionally that's in the public domain. But with that, I conclude my presentation on the design and development of a truly bespoke feature glass ceiling. And I say thank you to you all for bearing with me, and ask for any questions. Now, I'm not quite sure how the questions are going to be handled, but I shall stop sharing my screen and hand you over to...
Well, you can hear me, I hope, Anthony?
I can hear you, Chris.
Yeah, jolly good. Well, thank you so much. That is absolutely fabulous. Absolutely fabulous. I'm very jealous and envious that you got involved in something so fantastic. It's very unusual.
After the projects that you've introduced us to, Chris, and I must thank you for the introduction on a couple of the Maggie's jobs. The Maggie's jobs you've given us or introduced us to have given us the opportunity to work for a much lower margin than we normally do. So so doing a project like this hopefully occasionally gives us the chance to redress the balance.
Okay, all right, point taken, Anthony. When, as you say, I twisted your arm to do those 2 projects, and then I just walked away and left you with it.
Yeah, that was noted.
We've got some questions on the chat, which I'll read out in a moment. Equally, I think we're going to try and be very clever, and if anybody would like to raise their hands, we'll try and unmute you, and you can ask your questions over voice. But questions that we've got in here. Bruce Nicol. Hello, Bruce. Nice to hear from you. I don't know if you're out in Berlin still, but good to hear from you. Bruce says, how cost effective is extruding bespoke framing?
Depends how much you need, would be the initial response. We do it quite a lot, actually. Within IPIG, we're not tied to any particular suppliers. And so we will frequently look at a job and say, okay, it needs certain features, and it doesn't necessarily need other features. And, you know, we have extruded our own sections on I don't know, probably one or two, maybe 2 or 3 jobs a year we will extrude bespoke sections. One of the jobs we've just finished in London is a series of bespoke roof lights for BAFTA. Funny Bruce should ask that question, because he supplied the glass to us on that job and we extruded our own roof sections there. But no, we do it quite a lot, and it is, if it's designed properly and if it's thought through, then it can be extremely cost effective.
Do you, just out of interest, do you focus on one particular extruder? Are they UK or European based, or do you move around?
We tend to just get it from Richard Austin Alloys, actually. They have been a very good supplier for us. I think every time we've extruded our own sections, they have brokered it. Sometimes it comes from different lines, but yeah. All
right, thanks. Lucia Bravo, she asks, what drove the use of that many interlayers? Structural aesthetics requirements, or both?
Aesthetic requirements. Basically, the glass is, I think the largest panel is approximately 1.2 meters by about 500 millimeters. So, and there's no, other than dead load, other than self-weight, there's nothing really acting on it. So there's, obviously, with it being laminated annealed glass, it's not gonna fall out. No, the selection of interlayers was based entirely on the effect that we got with the backlighting. Okay,
I hope that answers Lucia's question. If not, Lucia, type another one. Darren Kent's being very cheeky. I'll just read it out. He says, can we have a cryptic clue for the location of the glass ceiling? I'm guessing the answer to
that. You can have a cryptic clue. It's in this country.
There you go, Darren. Over to you. That's the weekend sorted out. You can go and have a look around. Emmanuel Bringer, were spare glass tiles produced in case of replacement is needed in the future? Which was a question I wrote down as well. I'm sure many other people did.
No, actually. We have spare glass panel. Sorry, we have spare stock glass in the gold. We have spare chipped glass, but no, there are no spare panels because there's so many different panels involved on the job, or included on the job. The other thing is it's translucent and it's got a texture to it, and it's very strongly face lit and it's very gently backlit now. And if any of the panels crack, you can't actually see it. Because it's annealed, really? All you're going to get is one crack, possibly two, but you only really get one crack that meanders across the panel. And so you can't see, or it's very, very difficult to see a broken panel.
Did you break any in transit installation?
Can't possibly say.
Okay. So we'll take that as a yes.
Can't possibly say. But they don't bounce.
They don't. No, I bet they don't. Simon Vaughan asks, how was welding distortion in the fabricated extrusions managed? Good question. They're
actually all very light gauge. And you'll see that they're suspended at approximately, I think that the longest span is only 600 millimeters between suspension points. So it was possible to just bend them in certain directions. And so the way in which the framing went up, they came to site as 12 segments. Sorry, they came to site as 12 ribs and 12 inserted sort of frame segments. The 12 ribs were put up, and they sort of, obviously they'll sway around a little bit, they'll move around a little bit. You can just climb up on the scaffolding and give them a good shove. Then once you insert the inserted elements, the 12 sort of secondary frames, if you like, that pulls it all nice and rigid.
All right.
And you know, there's very little distortion. And then you think of the size of the gap between the edges of the glass panels and the frames as well. If there's 2 or 3 millimeters around the perimeter of every single piece of glass, then it's not an issue with distortion of the framework.
I just ask my experience of slump forming glasses, tolerance of slump forming can be an issue. So were you relying on the gasket system to take out the differential between the frame and the slump glass?
We initially relied on the gasket system to take out the differential. We ended up relying on wet sealant to take out the tolerance in certain locations, because for all of the field glass, if you like, all the stuff that's slumped to the same radius, about 8 meters, the tolerances were absolutely fine. But you're right to suspect that the tolerances on those funnel panels, the 12 central panels on each of the roof lights, it was still incredibly tight, but it wasn't really tight. You see what I mean? I think they did an exceptional job of making them, but there was still some tolerance that needed to be accommodated.
Yeah, good old sunglass. We've got quite a lot of questions and about 10 minutes left to run if we're going to be tidy. So we'll try and rattle through them a bit, Anthony. A question, what software packages did you use to produce the fabrication information? Did you export the architect's intent from Rhino into SolidWorks?
No, we developed the entire design internally, in-house, and we used Autodesk Inventor package. Okay.
Hopefully that answers the question. If you've got further questions, you can pop them up, and after we've finished, if there are any, I'll try and get Anthony to answer them and reply to you later. A question from Phil Reed, I think it is. Looks wonderful. Do you have a photo of the room showing the 5 glass ceilings? Particularly interested to see the sculpture. Also, the gold leafing of the frame. Assume it was necessary to remove the glass to achieve this. Is that the case? Was it?
No. In fact, no to every one of those questions. No, I don't have a photo of all 5 in a line, although I would love to be able to present it. It took quite a lot of arm twisting to actually be able to tell the story I've told tonight. So that was one of the questions. The gold leafing. No, the gold leafing was done with the glass in situ.
Okay, really?
It's yeah. I mean, I'm trying to remember the statistic. It was something like 1,500 linear meters of gold leafing. But if you're familiar with how gold leafing is done, it's basically, it looks like somebody's applying, obviously, gold leaf, but you use almost like the handle of a toothbrush to burnish it onto the metal. It's treated with a kind of an adhesive, very gentle adhesive, and then the gold leaf is burnished on afterwards. And there was sufficient lift on the glass panels. When the glass panels sit on the gaskets on top of the frame, that was sufficient height to be able to gold leaf the edges of the frame with the glass in situ.
Okay. Austin Higgins. Okay. Austin Higgins, I apologize if I haven't quite got the pronunciation right. I see that the corners and edges on the St. Martin's courtyard job have been rounded. Was there an issue on the presenter project with the stress concentrations on the glass panels and shattering? And was this something that was learnt from the residential project presented?
No. There was not an issue on the project I've just presented with any kind of damage at the corners. The St. Martin's job it had rounded corners because of the way in which the glass was processed. And so what we did on that job was we laminated all the sheets as large blanks, and then we water jet cut the individual triangles out of laminated stock sheets with a dichroic coating on. Right. The radius corners, if you think back to how the geometry works, it's a whole series of pyramid frames with the apex of the pyramid pointing downwards. So, and because there's 450 something or other panels of glass on the job, and you're working upside down on a scaffold, it's quite a mind-bending experience to glaze those frames. So what we did was we specified I'm trying to remember the details, but we specified about a 5mm radius on 2 of the corners, and we specified something like a 10 or 15mm radius on the corner that would point down into the apex. So the moment you picked up one of those pieces of glass, you knew just by looking at the 3 corners which corner was down into the pyramid. Okay,
so you made it mug proof.
Not entirely, but we tried.
Thomas Hendrickson says, have you had any problems with breakages? I think you might have mentioned that earlier, but have you had any problems? Has the client come back to you saying it's all fallen out?
No, it's been absolutely fine. No problems with breakages on that job.
And Simon Vaughan says, were the interior designers' expectations realistic?
I think they were. Yes. Yeah. It's worth one person I didn't actually mention was Max von Barnholt, who was the lighting designer from VBK Lighting, and through a very iterative process, we managed to get the end result that everybody was happy with. But there were moments throughout the process where that looked possibly out of reach. Okay.
I mean, there's nothing better than working with architects and designers who push you, and pardon the pun, as we always say, push the envelope. That's what makes what we do exciting and interesting.
Yes.
So yeah, okay. Particularly working with inspirational people, as you obviously have.
They had a very strong vision, and it's. I mean, I suppose one thing to take from the presentation, and one thing I take from the experience of being involved in the job, is that we learned so much from so many people as we went through it, and I'm not sure there are too many organisations out there that would take on the job. I mean, if you speak to Sunglass, they would never have taken it on. You speak to Pilkingtons as the original material supplier, they would never have taken it on. The guys who glue chipped the glass, they provide a fantastic product, but they wouldn't buy it at one end and do everything. They wouldn't deal with all the upstream processing and the downstream processing from their own stage of work. So we were able to pull together experience and expertise of an awful lot of people, both above and below us, if you like.
I think that's your signature. Anthony, you take on things that other people would run away from. We're getting down to the last 3 or 4 minutes, and there's just 2 or 3 more questions coming in. Simon Vaughan again says, what cutting process was used with CNC? What cutting process was used? Was it a water jet?
It was water jet.
Water jet. I think that's, which is very successful. Guillaume Laurent says, how do the acoustics work? Interesting question with hard glass ceilings.
If you look at the area outside of the glass ceilings, it might look like plasterboard in those finished photos, but it's not. It's an acoustic plasterboard. So the hourglass domes are what's the word? The rest of the finishes are very soft. Is probably the best way of putting it. And so yeah, you do get a little bit of I suppose a little bit of reverberation, a little bit of bounce back from the ceiling, from the glass parts, but the rest of it is very good at damping out the sound. And it's a private project, so it's never really particularly crowded inside.
I'm guessing that the thickness of their carpets will be slightly thicker than mine at home.
Good guess.
There's a gentleman whose name I'm impossible to pronounce, I'm afraid. He says, you said that the final product was not exactly what you would have wanted. What could you have done better or different? That's a challenge.
I think what I alluded to was that the final product, when we finished what we expected to finish, the combination of the mirrored glass and the backlighting, face lighting, and paint finishes didn't really come together in the way that everybody had expected them to. So that's why we ended up adding in additional, a fair amount of additional light to the visible face of the glass, and also adding the gold leafing to the framing.
Right.
We spent
Okay.
we spent a lot of time, and we probably went through 15, 20 different paint finishes on the frame during the development of the job, and presented them all, and people were very happy with them as samples. But once you got them up into the space, and the peculiarities of the orientation and the peculiarities of the lighting in that space meant that it just wasn't what people were expecting to see. So there was probably a good few months worth of follow-on work in fine-tuning the appearance.
Okay. There's lots of thanks and greats, and it was really interesting. Can I ask one question? It's 6:30. I'd like to just ask one question of my own, and that is, how do you clean it above and below?
You clean it carefully. The simple answer actually is that you lift the glass panels out and dust them. Right. Or rather, you can lift out some of the glass panels such that you can then clean the back of the panels you've lifted out, and you can vacuum the top of the panels that you've left in.
Wow.
It is as simple and as low tech and as manual as it sounds.
Okay, that sounds very precarious, and I wouldn't like to have the insurance policy doing that, for giving the insurance policy to the cleaner to do it.
You literally you just put. I mean, how do you? And I appreciate it's 6:30, but if you were going up in, I don't know what your house is like, Chris, but if you go up into the attic of your house, you just lift out the piece of wood that forms the hatch, and you stick your head up through the hole, and that's exactly how you clean this glass ceiling.
Okay.
It's a very low-tech answer to the final question, but
well, lots and lots of thanks coming in, and I'll add my personal thanks and the thanks of the SFE and all its members, and we've had a phenomenal turnout this evening. It's been really great. I think people from all over the place, Europe and further afield, have joined in this evening. Anthony, that has been absolutely superb. I knew you wouldn't let us down. I knew it would be really good, and you just stepped up to the mark, as I knew you would, as you always do. So thank you so much.
Chris, thanks very much. It's been a pleasure. I wish everybody a very enjoyable evening, if it is indeed evening where you are.
And I've just got one little piece of housekeeping. Thanks to everybody, ladies and gentlemen, for coming. Lots have turned up, very few left, which is really good.